think in reality, when we sort of have some sort of idea and we want to validate whether it's going to work, we just want to get to that point as soon as possible. And so I will try to sort of give you a bit of an overview of different techniques that allow us to do that. All right. Hey everyone, my name is Sash. I've been working at Facebook, Meta, whatever else for almost 7 years. And today I'm here to talk about power of prototyping. This is a bit of a time lapse of an assembly factory, which is a bit of an allegory to sort of process the way it's supposed to be done. And prototyping is a completely opposite of this. Not building things the right way, not writing tests, not, we're going to go through it in details. To begin with, I wanted to sort of ask, you can just shout, how long would it take you to build the app that's not just like your sort of toy project, but something, load some data from the internet, does some sort of user accounts, whatever. Look, you did it for the client, so how long do you think it would take you from the beginning to the end? Just give me a number. 2 days? 42 hours. Okay, great. Well, okay. 2 years, excellent guess. Okay, wrong, all wrong. No, I mean, it really depends on the app, obviously, but I try to just look up online. It seems like, on average, people say 4 to 6 months. Complex apps might be going to 9 months. We saw a lot of talks during the conference where through the architecture, through the tooling like Firebase, through SwiftUI, through absence of navigation stack, you can actually cut it down quite a bit. So you can actually get down to like a couple of months, maybe even 1 month, a couple of weeks, let's say. I'm here to tell you that you can actually do it within a matter of days, maybe even hours, if the goal is to just understand whether your idea is working. That's a big caveat. But that's sort of my point, that as indie developers, as people who work at big corporations and everywhere in between, I think in reality, when we sort of have some sort of idea and we want to validate whether it's going to work, we just want to get to that point as soon as possible. And so I will try to sort of give you a bit of an overview of different techniques that allow us to do that. In this talk, I'll sort of bring in a broad range of sort of examples both from hardware and software. For the past 3 and a bit years, I've been working on projects at Facebook that were sort of both hardware and software, iOS and Android, and everything in between, a bit of Unity too. Yeah, and so I'll just try to sort of go through this real quick. We're going to be done soon, don't worry. To begin with, I wanted to play a real quick game about what is this prototype. So I'll show you a few pictures, and if you recognize the prototype, again, just shout, what is your best guess? What is the finite product that this prototype represents? And so this is the first one. Some of you might know it, some of you might not. Any guesses? Hey, very well done. Okay, excellent Apple knowledge in the audience. How about this one? A bit different. It's a Game Boy. Where? No, it's not. How about this? Rubik's Cube. Yeah, it is a Rubik's Cube. Who recognizes this thing? Sorry? Very close. It is a handheld camera, the first digital handheld camera. How about that? That thing. Cell phone? Knife. Close enough. It's the first Fitbit. Now, because he was such a good audience, how about this guy? That is an iPhone. So this is a little known, like one of the versions of the UI that they built for iPhone 1. Legit, Apple built this, thinking that this might be one of the ways that people will interact. So before we actually had this, that was one of the teams that was working on this sort of interface inspired by iPod, right? And the last one, I promise, a computer, still iPhone, before minimization. This is how majority of the hardware projects start. They start as a mess of sort of components, and then they go through minimization process, sort of making them able to fit into this beautiful, sleek body. So what do they all have in common, all those prototypes? Well, they kind of like look meh. They don't necessarily look like the finite product. You can't sell them unless for the historical value, right? And so some of them tend to focus on an isolated set of features, not necessarily all of them. They kind of ignore, the rest of the features. Some of them might look bad, some of them might not work well with some aspects of usability. And so we will try to go and answer the question of why even to bother building prototypes? So there are multiple reasons to do that, and the first one I kind of touched on before, validate your idea. So what we see on the right is everyone's favorite project called Google Glass, right? And so when they started building it, regardless of what you think about finished products, when they started building it, there were not too many examples in the industry of similar devices, like heads-up display, always-on consideration and all that. And so they didn't really have any other products to reach out to and to ask questions of, well, how do you do X, or what is the best way to do certain interaction? And so they had to answer those questions by themselves. And so there is an excellent TED Talk by the person who was working on the project at the time. And so the very first version that gave them like quick sense of the heads-up display took them 1 day, and it was a projector that you used to use in schools that was kind of projecting an imagery on the plastic screen in front of you, just like head mounted to your head with a hanger, like a clothing hanger. And that gave them a rough sense of like, what does it feel to walk around and to see the image projected in front of you no matter where you look, right? So that's an interesting new concept that you never had before, well, maybe never had before. Next step would be, okay, well, you have some interactions with this heads-on display, right? And so they wanted to understand what it would feel like to interact with an imagery without actually touching it. So what they did, they had a system of polys sort of fixed to your two hands, and at the other end of the polys, there would be a clicker, kind of like this one for the slides. And so whenever you wave with your hand, it would click either forward or backward. And so that would do whatever contextual action. So it would like flick through emails, it would advance the photos, et cetera, et cetera. So this is a way to prototype, to validate ideas. You don't have hardware. It's like months or maybe years till you have it ready. But this is a way to actually to get there. Another one is saving time and resources. And you don't really have to read this code, but this is the first version of the Dropbox. Not really, but like this is what it could look like. It was a Python script that the founder of Dropbox wrote, and through that script, he saw that there is a massive demand in syncing files. Because I think the story goes that he would always forget his USB key, and like that sort of was annoying, and so he was like, oh, what if the files were just magically there? Python script is all it took. And again, it's not the question of like, what do you think about Dropbox as a software, as a company? This is what it takes to validate the idea, and this is the important part. Saving time and resources means not only validating that the idea is good, but also validating that the idea is bad. I don't know how many recognize this thing. That's Instagram, version 1.0, called Bourbon, location-aware social network. Needless to say, changed a bit ever since. You build something and you look at it and you see how people use it. There, they sort of saw that people used it to post a lot of pictures, and that's slowly what this thing evolved into. Learn from users. This is my favorite thing. So I think people will recognize this as an iPhone 3. But it's not an iPhone 3. It's an iPhone 4. And the audience probably knows that iPhone 4 was a massive redesign where they rebuilt the body to be this like sleek new design. But obviously they didn't want people to see that in the wild, yet they needed to test the device. It's a device that makes calls, it's a device that takes pictures. They wanted to know how it works in the wild. What they came up with is a brilliant idea. They were like, oh, we're going to build a case that makes it look like an iPhone 3. So I can walk around with it, make calls, and no one knows that it's not an iPhone 3. Well, it came with a problem. Does anyone remember what iPhone 4 was famous for? The reception thing. Yes. And so antenna gate was a result of this specific approach. Because when you walk around and you hold your phone by the case, you don't really make contact with an actual housing that houses the antenna. And so learning from your users means learning from how people use this. And I mean, here, again, this is a trade-off of like, oh, Apple is really secretive, and it makes sense to do this sort of thing. but it sort of resulted in not learning from the users, and that's something that you really want. So whatever it means in your case, learning from the users. And finally, you can use prototyping as future artifacts. This is, again, Dropbox. And this is an interactive prototype that a designer built when they were iterating on one of the features of Dropbox. It started as a static document, sort of describing what they're building, and it would never take off the ground. People were ignoring it, they were confused, they wouldn't understand. Designer went in and built an interactive prototype, including the macOS around it. This is all interactive, like the Wi-Fi switch is a part of the prototype. And so this is an HTML artifact that designer just shared with their peers. And the peers are like, oh yeah, cool, I get it. I can actually like open fake Photoshop, I can toggle the Wi-Fi, I can see what's happening there. And like that explained the project way better than anything else. It took off the ground. It started, basically they started virally sharing it inside of the company, and that created the momentum that was needed to advance the product forward. Not only that, in the future iterations, they kept building on this because it was a living prototype for the future versions. So hopefully that gives you some flavor of why to build the prototypes, and now is just a grab bag of things that's going to talk about how to build the prototypes. So there are multiple approaches to building prototypes, and I'll talk about 3 rough fidelity levels. There are many, many ways to slice this, but fidelity levels is basically what is the prototype, like how closely does it mimic the finite product. The first one is the paper prototyping. It's the very simple thing that you can do by just drawing on a piece of paper. You don't have to be a designer. You can see that it's sort of like very rudimentary sort of elements that kind of represent what you want to show. Again, depends on your use case. That is a fancy version of paper prototype where you can cut it out, you can move it around, but like again, don't worry if you don't do that. Medium fidelity prototypes are the prototypes where you are using one of those like fancy software. I'll show you a few in a second. That basically allows you for some pretty incredible interactivity. Some of them allow you to run it on device, some of them just show it you know, in the browser or what's not. But again, this is kind of like that Dropbox prototype that you can give to someone and they can play with it. It might be interactive, it might be sort of pre-programmed, you know, but that's sort of the point. Finally, there is a high fidelity prototype. This is the one that I built back in my Facebook newsfeed days. That was a project that we wanted to learn how this like animated post type would work, and it has a lot of aspects to it. It has like composer phase, it has a phase of like being rendered in the news feed, and then like what if the network is slow. So like you legit build this with the code, and you sort of play with it, you know, until people sort of get a feel of how it works. You know, here in the composer you can see that like typing back and forward, sort of like back and forth triggers animation. So like you kind of want to get a good feel of everything there, and so like. I think it's possible to do this with tools from the previous slide, but it's kind of tricky. So sometimes coding a prototype is the best way. So just to quickly sort of summarize here, again, 3 fidelities. They all have their own trade-offs. So some of them take longer, some of them, you know, are a bit quicker. Depending on what skill set you have or people who are available for this work have, you will choose one or the other. A bunch of tools, you know, on the right, you probably recognize some of them. Figma, Sketch, Framer, Protopie, Origami, and then Code, you know. So like, they got shout-outs throughout the conference. I won't like pause on this for too long. So those are 3 sort of different ways to slice, you know, the fidelity of the prototyping. Now, next section is about design space. And so design space is this really sort of interesting, depending on how ambiguous your prototype is, like what's the space that you operate in, you want to understand what are the different sort of points in the space that you need to explore. So again, one of my favorite examples here is, this is a story of creating keyboards for Apple, for iPhones. There is a really cool book, actually, that covers this process in excruciating details. Really lovely. Highly recommend it. I will post it later. But basically, yeah, on the left, we can see that one team explored this kind of click wheel keyboards, pretty cool. In the middle, a couple of explorations with kind of, if people remember T9 phones, like that's the thing. So basically, it clusters several letters onto the button. An interesting aspect here is that on the touch screen, you don't really have like a physical button, so you cannot really like type without looking, right? But then an interesting take on T9 is that keyboard in black that actually takes the regular layout and just clusters the keys. So like no matter where you press within QWE, it kind of counts it as 1. And when you have 3 letters that you've tapped, it will look into the dictionary and it will try to guess what is the word that you tried to tap. So like, again, a really interesting exploration, and I'm kind of curious to, I would be curious to learn what are the results of that. And I mean, obviously, finally, the classic QWERTY that sort of works out eventually. But again, if you look in the App Store, people are still exploring various directions here. And I think Adam here has an app in the App Store that has a click wheel keyboard that works incredibly well up to this day. So you should download it and try to type an email or something. That's pretty neat. So this is the design space. Again, it's sort of trying to work with whoever the product is or you by yourself, and trying to understand what is the space that you operate in, what are the points that you want to explore, and sort of create some artifacts that allow you to understand it better. Next consideration is, do you want to build this prototype standalone or integrated? And there are different trade-offs here, and the one that I touched on before, the one that shows sort of prototype integrated into like real-life newsfeed app, is sort of an integrated example. You can also build standalone ones. They all have different trade-offs. Depending, for example, on how much you care about leaks and secrecy, you might not want to ship it in your production app. Depending on how much you care about code complexity or code reuse, again, those are different trade-offs. I don't think that there is one right answer. You should rather sort of look into it by yourself. Next point is about private API, and this is honestly my favorite. So this is a prototype, so unless you ship it in your production app, you don't care about usage of private API. And I really, really love swizzling, private API, disassembling stuff. You just look into how Apple does stuff. So at some point, I needed to prototype something for the watch, right? Like Apple Watch. And so that was before SwiftUI. And before SwiftUI, this is how we would build stuff for Apple Watch. And I was like, this is horrible. I mean, this is slow. I cannot even give it to designer and let them play with it. So instead, I built a little thing. This is Framer, a macOS app built by a company called Framer. And so this is the prototype, just a test prototype that I think comes as one of the examples. So I built an app that basically scans the link from Framer and then creates a web view on the watch and sends this prototype over to the watch. So the web view on the watch is the private API, right? Like, it's not something that we can actually use. I don't know if today is the case. Back in the day, definitely wasn't the case. So it was so much fun, though. Like, you can give this thing to your designer, and that's it. You walk away. Like, they start playing with it, and they start putting together whatever prototypes they want. And so you can enable their own explorations. And again, just because this will never go to the App Store, you can do it with test flight. You can obfuscate the API usage, whatever, or you can just install it on their device. And that's it, you're done. So private API is actually cool in prototyping, and those who like to play with it, this is your playground. Prototyping is also about just moving fast. The value of prototype in the fact that it's faster than the actual app development, and next 2 slides are kind of touching on that. So everyone here is acutely aware that iOS community is actually great because we build and share a lot of high-level components. Those are some examples of UI components that are all open source, all on GitHub, and there are repositories like this, Awesome iOS UI, that just aggregates tons of them. And so you can go in there and you can just pick what works well for you. You don't really have to have it look as exactly like you want or whatever. Like, if that's not the point of your prototype, just have something that works close enough to what you need. And this is pretty cool. It sort of allows you to just pick component that works for you and just run with it. Next point is similar, but kind of higher level. There are also open source apps. Like, all those apps, Spotify, Clone, that's an actual Firefox, that's a Proton Mail, I think. And there are many, many more, Wikipedia, whatever. They're all open source apps that you can actually install on your simulator today. And then when you actually want to prototype, let's say, a new player UI, but you don't want to build everything around it, so what you do, you install, you can clone the repository, you actually import your own player UI, and replace them. Integration can be hard, but again, that's a trade-off. If you want to set up a good context for your users, for the users of your prototype, then this is a really good way to play with it. It kind of allows you to have a natural experience, and then at some point, swap out, for example, player UI for the one that you're prototyping. Next one is my personal pet peeve, placeholder data. So when you're building your prototypes, and sometimes even sort of real apps, try to avoid using the dummy data like this or like GUIDs or whatever for like instead of labels. It just doesn't mean anything to the user when they actually play with it. It just robs them of a bit more context. Prototype is valuable because it conveys some sort of idea. And so this is a piece of fake data that I just set up, over like 5 minutes. And it actually conveys way better that, okay, this is a list of films. This is not a list of podcasts. This is not a list of audiobooks, a list of films, right? And so this is super valuable. So try to avoid placeholder data kind of like this, the dummy one, and use something that actually conveys what is the story of your prototype. There are super useful websites that can generate entire sort of fake personalities along with emails, credit cards, profile pictures. Everyone's favorite ChatGPT these days can generate like literally JSONs full of people, with their favorite emojis and artists and foods and whatever else. So try to avoid it. It just gives a bit more context to your users. This one is about latency. And the point here is that some technologies might not be quite there in terms of how performant they are. But again, if that's not the point of your prototype, you will just lose your people, on your users, on sort of how long it takes. And so the example on the left is something that I built just to explore the concept of what if you would have different tonalities that you can sort of apply to a text, like friendly, angry, whatever, working in the same way as just the text formatting, like bold, italic, whatever. So it works instantly. And so that's what I wanted to explore. And so in this video, I just cut, the part where I'm waiting for it it's using also OpenAI sort of stuff, but I cut out the parts where it's actually making the query. And the final sort of video gives me a way better sense of what it feels like. You can also just fake the data. So in that example, I actually did the queries in advance, sort of batch them, and then it works instantly. So again, it just sort of allows me to understand, okay, what would it feel like if immediately after I'm getting a new email, my email client pulls out like the summary of the email instead of the subject. It pulls out some actionable, links from the email if I want to like log in and, I don't know, do something or whatever. It pulls those things out. So it doesn't take as long to actually load it up. My personal favorite time machine. So one of my previous teams is called Control Labs. It's the team that built an incredible brain-computer interfaces startup that Facebook acquired a while back, part of FRL. And so what you can see here is the real demo that we built, and we showed it during one of the conferences a couple of years ago, where this guy scribbles on his leg, like there is nothing else there except for this bracelet that you can see on his arm. He scribbles on the leg, and in real time, we translate it into letters. Like, that alone is mind-blowing. But then, sort of, this prototype works really well for this person, but at the time, the model that we used to recognize your muscle activity was kind of highly personalized to the person who it is trained on, and so it's hard to pass it over to another person and to let them play with it. So to solve that, we did a pretty simple trick. So we took Google has this like handwriting recognition framework that we took. I wrote an iPhone app, really simple iPhone app that is like a full screen handwriting recognition, right? You can also do the same thing with private APIs from, I believe, in iPadOS. So when you actually write with your finger on the phone, it recognizes letters, then words, then whatever, and sort of sends it using the same protocol. So we were using Microsoft HoloLens to actually render the UI that you saw in the previous one. And so it sends it using the same protocol to the HoloLens. That one speaks Unity, this one speaks iOS. We also use that little sort of running handband to fix it to your leg. So you have a full iPhone on your leg, and you use your finger to like scribble in there, and it sends the text into your HoloLens UI, and that allows you to take out this component that was not ready for other people to try. And so think about it in terms of when your backend team is not ready with some sort of integration, or when some technology is just not there yet. Try to imagine what can you replace it with? What can give you the same outcome without waiting for the technology to be ready? So like now we're all waiting for like a new toothbrush or whatever. Think about what would be a good proxy, if you want to play with it. So like you can take a phone, you can render UI on your phone, find a way to mount it to your head, done. You're already there. You're going to be the first app on the App Store. Yeah. So this is a grab bag of tips. To recap, try to learn how to validate ideas, to save time, to learn from your users, to build future artifacts with prototypes. We talked about different fidelities that are available to you, from low, medium to high. We looked into design space and how it might be useful to sort of explore different parts of it. We talked about different trade-offs of integrated and standalone prototypes. Private API and how cool it is that we can actually use it for prototyping. All sort of high-level primitives that are available to you as a prototyper to accelerate the process and to get to the results much sooner. Trying to set up more context for your user by avoiding dummy data and sort of using whatever tools necessary to give more context. And yeah, finally, the time machine. So a way to accelerate development by sort of replacing the pieces of the technology that's just not ready yet with something that's there for you and still allows you to convey the idea of the prototype. Yeah, basically, the goals of all of that is to give you the, the goal of all of those tools is to give you the agency. All too often, software engineers are waiting for a designer, for the product, for whoever, to tell them what to do. You have incredible ideas, and a real prototype gives you way more agency, and it gives a way better sense of what the idea would feel like when you show it to others. Next time you're waiting for a designer to come up with an idea, maybe just build a quick prototype and try to get your idea moving. Thank you so much. Thanks, Swift Heroes.